Hello students, my name is Hemchandra Bhatt. I will solve a couple of integration problem for you. You can see the problem on the screen. They have given us x equal to sine theta. This is what we have to use. So, x equal to sine theta. This is what we have to plug in. We have to differentiate with respect to theta. So we get dx by d theta equal to cos theta. Now, dx can be written as cos theta d theta. So let's plug in these values in this equation. Integration x square is sine square theta divided by under root 1 minus sine square theta. And we have dx. We will write cos theta d theta, or we get sine square theta divided by 1 minus sine square theta. It is cos square theta. This is a Pythagorean identity. So we can write cos square theta, cos theta d theta. Now, under root cos square theta is cos theta. So we get sine square theta upon cos theta into cos theta d theta. Now cos theta gets cancelled and we get sine square theta d theta. It can be written as 1 minus cos 2 theta. It is a double angle identity. 1 minus cos 2 theta upon 2. So we got 1 minus cos theta, 1 minus cos 2 theta divided by 2. Let's move on. Now we have to integrate it. 1 by 2 and then 1. The integration of 1 is simply theta minus cos 2 theta, integration of cos 2 theta d theta. We can use the substitution method here. Let us suppose 2 theta equal to u. It means 2 equal to du by d theta, or we can say d theta equal to 1 by 2 du. So we can use this substitution here. We can write cos u into d theta. D theta is half du. We can write it as 1 by 2 theta minus 1 by 2 into 1 by 2, that is 1 by 4. We are distributing this 1 by 2. Cos u, the integration of cos u is sin u, and then we can write plus c. C is the constant of integration. Now we have to write it as 1 by 2 theta minus 1 by 4 into sin u, means sin 2 theta plus c. Now we know that sin 2 theta, we have a double angle identity, sin 2 theta equal to 2 sin theta cos theta. We have to plug in this value, 2 sin theta cos theta, into this integral we got. So this is what we now have. Let's move on. We can simplify it further. 1 by 2 theta minus 1 by 2 sin theta cos theta plus c. And initially we assumed x equal to sin theta. It means sin inverse x equal to theta. And we know that Sine square theta plus cos square theta equal to 1. It means cos square theta equal to 1 minus sine square theta. So we can say cos theta equal to under root 1 minus sine square theta, or cos theta equal to under root 1 minus x square. We have to plug in these values into our integration we got. So we get half into theta. Theta is sine inverse x, minus half into sine theta. Sine theta is x, and cos theta. Cos theta is under root 1 minus x square plus c, and 1 by 2 can be taken as a common. So we get sine inverse x minus x under root 1 minus x square plus c. Let me explain the key steps again. First of all, we differentiated x and we got dx by d theta equal to cos theta. We got dx. After that, we substituted our values. X equal to sine theta and dx equal to cos theta d theta. After that, we simplified it, and at the end we got sine square theta. We used the double angle identity and we got 1 minus cos 2 theta divided by 2. So the integration of 1 is simply theta, and cos 2 theta, its integration is sine 2 theta upon 2, but this 2 is in multiplication, so we got sine 2 theta divided by 4. Sine 2 theta is 2 sine theta cos theta. So we simplified it and we got sine theta cos theta divided by 2. Now, we know that x equal to sine theta, so theta equal to sine inverse x, and we used Pythagorean identity and we got cos theta equal to under root 1 minus x square. After that, we plugged in these values and we got the answer. I hope that helps. So this is the second problem. I will explain. Now, they gave us the hint that we have to assume x equal to sine square theta. X equal to sine square theta. So first of all, we have to differentiate it with respect to theta. So dx over d theta equal to derivative of sine square theta with respect to theta. Now, we have to use the chain rule. So sine square theta. Sine square theta, we can assume sine theta equal to u. So we got u square and u is sine theta. We are using the chain rule. We have to differentiate derivative of u square with respect to u, and we will get 2u. We use the identity x to the power n. Its derivative is n x n minus 1. So we get 2u here. Now u equal to sine theta. So du by d theta equal to the derivative of sine theta is cos theta. Now we have to multiply these derivatives together. We will get 2u cos theta, or 2 into u. U is sine theta. 2 sine theta cos theta. So this dx by d theta is 2 sine theta cos theta, or we can write dx equal to 2 sine theta cos theta d theta. Now we have to consider the limits now. This is dx its lower limit is 0. The lower limit of x is 0 and the upper limit is 1. So, and we assumed x equal to sine square theta. So, if we assume x equal to sine square theta, let us consider the lower limit. So, 0 equal to sine square theta. And we know that sine 0 is 0. So, theta equal to 0. This is the lower limit for theta. Let's consider the upper limit. Upper limit is 1. So, 1 equal to sine square theta. And we know that sine pi by 2. Sine pi by 2 is 1. So, theta equal to pi by 2. We are dealing with the non-negative numbers. That's why we got 0, theta equal to 0 and theta equal to pi by 2. Now we have to plug in these values into our integration. Let me put these steps on the board. So this is what we have done so far. Let's move on. Now we have to write our integration. The lower limit is 0, 1. But now we got our limits are lower limit 0 and the upper limit pi by 2. Under root x. X is sine square theta upon 1 minus sine square theta. And dx. Our dx is 2 sine theta cos theta. So let's simplify it. Under root sine square theta. So sine square theta divided by 1 minus sine square theta is cos square theta. This is a Pythagorean identity. So cos square theta, but we have its under root. It means we have sine theta divided by cos theta into, this is 2 sine theta cos theta d theta. 2 sine theta cos theta d theta. It means cos theta gets cancelled and we are left with 2 sine square theta. We can write 0 to pi by 2, 2 sine square theta d theta. And earlier we used a double angle identity, 2 sine square theta. It is 1 minus cos 2 theta. Now we have to integrate it. So the integration of 1, it is theta minus cos 2 theta. Its integration is sine 2 theta divided by 2. We discussed it in the previous section. So this is our integration. Now we will not use plus c because we are given the limits. So we will plug in the limits. The lower limit is 0 and upper limit is pi by 2. So these are our steps. Now we have to plug in the upper limit and then lower limit. After that we will do the subtraction. So we will plug in pi by 2. If we get pi by 2 minus sine 2 theta. Sine 2 theta is 2 into pi by 2. Sine 2 theta divided by 2. And if we calculate it, we will get pi by 2 minus sine pi. Sine pi is 0. So we get pi by 2 if we use the upper limit. Now let's use the lower limit. So the lower limit 0 minus sine 2 into 0 is 0 divided by 2 and it is 0. So if we plug in the upper limit, we get pi by 2. When we plug in the lower limit, we get 0. Now we have to perform the subtraction. Pi by 2 minus 0 is pi by 2. So this is our final answer. Let me put this part on the screen. So this is the whole solution of our problem. Let me explain the key steps again. The most important step is the derivative of sine square theta, because we are given x equal to sine square theta. While finding the derivative, we have to use the chain rule. Sine square theta, we assumed u equal to sine theta. So what we did, we differentiated u square and we got 2u. We differentiated u square with respect to u, and then we differentiated with respect to theta, we got cos theta, and then we have to multiply them together and we got 2u cos theta, and u is sine theta, so 2 sine theta cos theta. So dx by d theta is 2 sine theta cos theta. We get dx equal to 2 sine theta cos theta d theta. Now we manipulated our lower limit and upper limit. You can see that the lower limit is 0. If we put x equal to 0, x is sine square theta, we get theta equal to 0. When we put sine square theta, x is sine square theta and it is 1, so sine, and we know that sine pi by 2 is 1, so theta equal to pi by 2. These are our upper limit and lower limit. After that, we plugged in the limits and we plugged in the value of x and dx. We simplified it at the end. We used double angle identity and wrote 2 sine square theta as 1 minus cos 2 theta. The upper limit is pi by 2, the lower limit is 0. We plugged in pi by 2, we plugged in 0, and then we performed the subtraction. So this value is pi by 2, this whole is 0, pi by 2 minus 0 is pi by 2. I hope that helps.